Yes, children. So we learned about air. Air is a mixture of gas, isn't it? What all gases are present in the air and how they are useful to us, that we learned. Then we learned about the atmosphere, the layers of atmosphere, how it protects our life, how the atmosphere protects us from harmful radiations of the sun. Then we learned about the properties of air. We learned how these properties are using in day-to-day life. Windmill, uses of air exerts pressure, in how it is applicable in our day-to-day life. So not only air we need, isn't it? We need water also. It's very important for our life. So now we learn about water. Water. Life, both animal and plant, is impossible without water. Without water, men die of dehydration. If we won't drink water, if in the lack of water, or if no water in the body, what happens? Yes, man will die. We die. About 70% of human body is comprised of water. 70% of our body consists of what? Water, isn't it? Human body, 70% in our body, the thing is what? Water. Of the total surface of the earth, 75% of water, and just below the surface of the land, in most areas there is saturated layer known as water table. Our earth, most portion of the earth, we say, or 75% of the earth is covered with water. That also we learned, we know. Human body, 70%. Our body, 70% of our body is water, and in earth, when we talk about earth, in earth, most portion of the earth is covered with water, and also we have water below the surface of the land. Underground also we get water, that is called saturated layer, we say. Under the ground, rock, many rocks are there, some pores of rock, if we break it we get water. It is called water table. Okay, now water dissolves in many things. Uses of water, we learn how the water dissolves. Put some salt in a bowl of water. Take a glass of water and put a little salt in it. What happens? Just stir it. Stir the water with a spoon. The salt disappears. Can you see salt content there? If you put salt in a glass of water and stir it with a spoon, what happens? We won't able to see salt there again. Isn't it? That means salt disappears. Magic, isn't it? Salt disappears. We put salt, but it's not seen. Why? Now taste the water. You can feel the salt, salty. Taste is salty. Where did the salt you mixed go? The salt you mixed in the bowl of water did not disappear, but it dissolved in water, we say. When we put salt in water and we stir it with a spoon, we won't able to see salt again there, but when we taste it, we can feel the taste of the salt. It doesn't go everywhere. It dissolved in it, we say. Salt dissolved in water. So that's why water became salty. The salt and water together form a salt solution. When we mix salt in water, then the water became salt. So salt solution, salt water we get, isn't it? Salt water we get. When we mix salt and water, we get salt water, isn't it? So this salt water is nothing but, this is a solution, we say. This is a solution. This is a solution of what? Salt and water. The water here, this water is called solvent. The water is called solvent here. And salt, that the substance that dissolved in water, it is nothing but solute, we say. Okay, so solute plus solvent gives solution. Solute plus solvent. Solute and solvent, when we mix it, we get a solution. Okay, children, when we mix salt and water, we get salt water. So when we mixed these two substances, we get some solution. So this substance which we add to water, it is solute, and the water is called a solvent. Water is always called a solvent. Okay, substance we added to water is called solute. So solute and solvent, when we mix it, we get a solution. Okay. Then water here is called solvent. Salt, the substance that dissolved in water, is called a solute. And repeat this experiment with sugar. Thus we can understand, or we understood, that water dissolved in many substances. So not only water dissolves in salt, and salt dissolves in water, we can do the same experiment using sugar also. If we put sugar in the water, sugar also get dissolved in water. So we can say sugar plus water. Sugar is the solute there then. So then solvent is water, we get sugar water, or sugar solution we get, isn't it? So we can say that water dissolves. It dissolves many substances. If we put any substance to water, it get dissolved in it. Okay. Now, impurities in water. Water is the universal solvent and are in nature. It is never totally pure. We can say water is a universal solvent. Which is a universal solvent, children? Yes, water is a universal solvent, we say. Okay. But everywhere water, we can see the presence of water here and there. Water is there in the river, in the ocean, in the lake, in the pond, in the well, in the tap. But all these waters are not pure. We can't say they are very clean. Okay, it will always have some chemicals, gases or minerals in the air. Then soil or rock are dissolved by the water. In water, we won't able to see the presence of these things in the water, but water consists of all these things: soil, or these minerals, or we say gases, rock. It dissolved in it, so we won't able to see it, just like salt dissolved. We won't able to see these impurities in water. It is dissolved in it. Some dissolved materials give water its characteristics, taste, and pure water is generally considered to be lacked and tasteless. Pure water, actually water, we say it is colorless. We say water as it is, no color and no taste also. We never say that water is tasty. Water actually is tasteless, but when we add some substance to it to make it taste, then it becomes taste. Minerals can cause hardness. I told some minerals are present in water. Minerals means calcium or magnesium, then some iron. Then arsenic is contamination, means contaminated means making something impure, not pure. Some contaminated substances we say, some impure substance, not pure. And radioactivity is a waste, a nuclear waste we say, like radium, radon in the water. These kinds of things are present in the water that we won't able to see. Actually, minerals, ions, then this nuclear waste or arsenic means contaminated things or impure things are present in water. Human can cause contamination through the improper use of pesticides or fertilizers and through the disposal of waste. These human beings, they are contaminating the earth, or we say because of their activities, what is happening, they are using pesticides. They are chemicals actually, fertilizers. If they are not using chemical fertilizers, chemicals they use to add to the soil, what happens that time? It is spreading to the air also. Through air it will go to water also, and air gets contaminated. At the same time water also get contaminated. Because of the waste disposal, we throw here and there waste, and from the waste also what happens? Yes, air gets polluted, even water also. These impurities can dissolve in the water, causing it to be contaminated. Because of all these things, water gets impure, we say. Minerals and impurities are normally present in very small concentration. Minerals and impurities are present in the water, but in small quantity, we say. Okay, so there are many impurities present in the water. It is dissolved in the water, so water is not pure as it is. We have to make it, filter it, and we have to make it pure because of the activities of human beings by throwing waste or by adding fertilizers, chemical things to the soil and all, making the water polluted or contaminated. So because the water is impure, we have to make it pure. So what we do to make the water pure? What steps we have to take to clean the water? That is the next topic. Okay. Yes. So how to remove these insoluble impurities? Okay. So first method is sedimentation. Okay. Sedimentation. So let's see what is this process. It's a process of removing the impurities from the water. Okay. Sedimentation. Take a glass of water, put some mud in it and stir. Take a glass of water, put some mud, then you stir it. Okay. Does the water becomes muddy? Let's see. Now let us keep the glass undisturbed for 10 minutes. Takes a glass of water, put some mud, stir it and keep it there. Don't disturb it. Let it be there. For 10 minutes, let it be there. Then we will find that the insoluble mud particles settle down at the bottom of the glass. Mud, it is not like sugar and salt. It won't dissolve in the water as of a sudden when we put it. Okay. What happens? It won't dissolve. So it after 10 minutes it gets settled down. All the mud will go down in the water and it will be there, settled down at the bottom of the glass, leaving the clear water on the top. We can see the clear water on the top. All the mud particles go down to the bottom of the glass and only the clear water we can see the upper part. In the upper part, the mud that settled down, that is known as sediment. Okay, the mud that is settled down at the bottom of the glass, it is called sediment. Now carefully pour out the clear water into another glass. So now already all the sediments, or we say the mud, is at the bottom. Now we can carefully, you have to take the glass and you have to pour only the clear water. Now this is the way how we get a clear water. The sediment is left behind, the mud particles, the impurities we say, they're left behind. The process is known as decantation. This is also known as decantation. Decantation. The process of removing the sediments from water is called decantation. Decantation. Separation of sediments. But removing insoluble impurities by sedimentation. The process is called sedimentation and the removal of the sediments is called decantation. You can see the image there. Okay. How in the beaker, see the particles are there in the water. The first image you can see particles suspended in the water. Then the second image you see these particles get settled down in the bottom. It was there full. Then after some time you can see these particles there down at the bottom. And after the particles get settled down, take the clear water and pour to another glass. We get the clear water there. Okay. Next is another process. It is called distillation. This is also a process of removing impurities from the water. Okay. How? Collect some impure water, salt dissolved. Impure water means salt water we can take in a conical flask. See the image of a conical flask, children. This is called actually the conical flask we say. We use this kind of flask in the laboratory and all to do experiments. Okay. So we have to take salt water in this flask. Then you have to close it with one hold cork and insert a glass tube to it. You have to close it with a cork, with a lid, and you have to insert a glass tube also. These are the things we use in lab. Okay. Then connect other end of the glass tube to another conical flask which is closed with one hold cork. So now there are two conical flasks. One flask already we covered, we close it with lid and we insert a glass tube to it, and this end of the glass tube we connect it to another conical flask and it is closed with also a cork. Okay. And you have to boil the water. Which water? Salt water in the conical flask. After some time you can see the vapor passes through the glass tube. The salt water is boiling, right? So what happens? The vapor, from that vapor will pass through the glass tube and condenses to form water in the second flask. And the vapor, it passes through this glass tube and it goes to the second conical flask. Then water thus obtained is so pure, and the process is called distillation. So this is the process by how which we are taking pure water from impure water. This experiment you learn in higher classes, children. This is a laboratory experiment. Actually, we have to experiment it and learn. Okay, so details you will learn in the higher classes. Actually, you should understand that distillation is a process of separating the impurities from the water. Impurities we will remove and we get the pure water. Distillation is a process of removing the impurities from the water. Okay, so experiment they have given this, but they have not shown the picture, but we have shown you the image of a conical flask and a glass tube, filling the how to insert it, and when we heat the salt water in the conical flask, the vapor it passes through the tube and it goes to the second conical flask and we get the pure water. This is the method of purifying a water called distillation. Okay, so there are two processes we learned to clean the water. One is process of removing the sediments from the water. It is called decantation, and the other is process of removing the impurities from the water, which is called distillation. Okay. Now it's time to recall. Okay, the atmosphere extends to several hundred kilometers above the earth. It protects life on earth in various ways. Atmosphere, layer of air surrounds the earth. It protects our life in different ways. Air is a mixture containing 78% nitrogen, 21% oxygen and 1% other gases including carbon dioxide. It also has dust, smoke and water vapor. These all things, gases are present in the atmosphere. Main gases are nitrogen and oxygen. Other gases are present in very small quantities. Air occupies space and has weight. It is needed for burning. So we learned about the experiments, how air occupies space, or how air has weight, isn't it? How air has weight experiment is how we take two balloons filled with air and we tie them in the stick, and using a thread you have to hold the stick. The stick is straight now. Stick is straight, it is balanced. We say when we prick a balloon with a pin, what happens to the stick? It will tilt to one side. This balloon is pricking one side, one balloon we will prick, so this automatically that stick goes to the other side where the inflated balloon is there, isn't it? That means air has weight. Then air occupies space, I said. How? If we fill a deflated football using air pump, we are filling the air into it, then what happens? The air fills the space and football takes the shape, that round shape. That means air occupies space. Or filling air into the balloon also, same thing, no? It fills the space of the balloon and balloon gets its shape. So air occupies space, we say. And air is needed for burning. How? Suppose you are taking a candle. Take a candle and light it. It will burn, isn't it? And suppose you are taking a glass and you are closing that candle. What happens? Suddenly that flame will go off. It will get cut off. Why? What happens? Because there is no oxygen now. The air it is getting, that's why flame is there. When we lighted, the flame was there. It is continued to burn if the oxygen is there. But if we put a glass tumbler upon that candle, slowly that flame will go off. Why? Because it is not getting the air, isn't it? So air is needed for burning. Understood? Just take a candle, light it. It will burn. After a few seconds, take a glass tumbler and close the candle. You can see slowly that this flame will go off because air is not there. Now you covered it down. So air is needed for burning, or we say oxygen supports burning. It is needed for burning. It's another property for air. Then air exerts pressure in all directions. That experiment also we learned. Taking a glass full of water, then we have to hold it in the left hand, and we have to cover it with a cardboard firmly, tightly. Then we have to invert it, and we have to slowly take off the right hand, but the cardboard do not falls down because of the pressure acting on it. That means air exerts pressure. If we open a perfume bottle, suddenly we can experience the smell of that perfume in the entire room, isn't it? That means air spreads in all directions. Or if you light an agabatti stick, agabatti in any corner of the house, that smell suddenly spreads everywhere in the house. Air spreads in all directions. Then we learned about water. Water is very important to all living things. Harmful impurities in water have to be removed to make it fit for drinking. Water is not pure. Water we can see everywhere in the land, on the earth, but it is not in the pure form. So to make it pure for drinking, we need to purify it, filter it, isn't it? To remove the impurities. Distillation is used to remove soluble impurities in water. Distillation is a process of removing the soluble impurities in the water. And decantation is used to remove the insoluble sediments from the water. So these are the things we learned in this lesson, children. So our lesson was air and water, and we learned about air, the different gases present in the air, about the atmosphere, the layers of atmosphere. We learned how the atmosphere protects the life we learned. Then we learned about the uses of gases in the air. Then we learned the properties of air. Then we learned about the water, how water is important to our life, isn't it? Then we learned about the impurities in water and how to remove these impurities during different processes.